Hey, this is Dr. B, and here's a short video about the challenges of synthesizing Remdesivir. The chemical structure is shown right here. This is a molecule with a molecular weight of perhaps 300 grams per mole. It's got 6 chiral centers, which can make it challenging to synthesize since you have to get not only the connections right, but their three-dimensionality as well. Chemists call that the stereochemistry of that. And this outlines the synthesis of it. I'll go over the general steps and the yield they get for each of them, starting with this molecule there, which you have to purchase. It's not just naturally available. Combining with this thing in the presence of N-butyl lithium to remove an acidic hydrogen, you end up with this substance here, and then you go through about 4 additional steps to end up with your product, Remdesivir, which is 4B. The yields for some of these steps are very low, 25% there, 60% there, 21% there. So if you take each one of the percent yields and multiply them by each other, you see that overall you get less than a 1% yield. That's not great. That means if you start with 100 grams of raw materials, you'll get less than 1 gram of product. This three-dimensionality is very challenging. If you compare it with a structure like hydroxychloroquine that has only 1 chiral center, the complexity of making it three-dimensionally correct are much harder for a molecule such as this. You have 6 chiral centers. You start with a substance which has the right absolute stereochemistry, meaning that if that was your first stereo center right there, it's not its mirror image, it's the correct one. From moving forward from there, everything else is topologically correct relative to that. So this is coming out of the plane of the board there, but this one's going into the plane of the board. So you have to get both the absolute and the relative stereochemistry just the way you want it to. This step here, I don't know if you can read it, but it says chiral HPLC. This is a technique that removes the unwanted stereoisomers, which can be a tricky thing to do because they have such similar chemical and physical properties to the desired compounds, but your body would know the difference. So, stereochemistry is challenging. The current supply, however, that they have, at least as of recently, was enough for 140,000 courses, each one consisting of a 10-day regimen for this injectable. This is not a pill, this is an injectable, and you got to make sure that you are synthesizing something that is truly food grade, clean room conditions, so that you don't have any impurities in this substance. The need is massive, and this really is usually something that gets the pharmaceutical companies very excited since they have a huge market cap. They have to balance the need that humans have for this against their desire to make a profit, obviously. But let's suffice it to say that there's a giant need worldwide for this substance. They do have previous experience in this area. It's not like they just say, oh my God, we've never made something on this level. Consider, for example, this substance here. This is Tamiflu, which I've taken myself and found to be personally very effective. And for that, they've created a worldwide supply in combination with other drug companies of over 200 million courses for this. My primary source for this was a recent article in Chemical Engineering News, and there's a link for it if you're interested. I also took advantage of an excellent presentation by Julia Gangemi on this subject also. Thank you, Julia. And one thing that the news article points out is that it's kind of like making cars. You know, if Toyota is making a car, or Chrysler for that matter, it doesn't mean that every part in that car is manufactured by Chrysler. Far from it. It's kind of like what Chemical and Engineering News refers to as a bucket brigade. This substance might come from Pfizer. This substance here might come from the Aldrich Chemical Company or some other source. So you take advantage of worldwide sources to synthesize the whole thing together. No doubt Gilead is heavily patent protected on this, so that the profits for this drug, if and when it gets sold on a massive scale, which it probably will go to Gilead for a generation, 17 and a half years. Okay, that's an overview of the challenging aspects of synthesizing Remdesivir.